Welcome to the Digital Twin Files. Today, we're going to cut right through the hype. We're talking about what it actually takes to design, develop, and deliver the kind of high fidelity digital twins our cities and infrastructure desperately need. This is the real professional's guide to building that secret mirror world, the ultimate what if machine. I mean, that's really the heart of it, right? At its core, that's the whole promise of the digital twin. It's this safe virtual playground where we can simulate, test, and perfect solutions for our cities before a single shovel hits the ground. It's about flipping the script from being reactive to being predictive. So the big question is, how do we actually get there? How do we make this thing real? Here's our game plan. We're going to follow a logical path, starting with the big picture, the city's secret mirror. Then we'll dive into the nitty-gritty of data, going from chaos to order. After that, we'll talk about making the model intelligent, tackle the all-important human-machine challenge, and finally, wrap up with how this all leads to building more resilient futures. All right, section 1, the city's secret mirror. We're talking about moving from a static copy to a living, breathing model. So let's get one thing straight right away. A digital twin is not just a fancy 3D model. Think of a 3D model as a photograph, a snapshot in time. A digital twin, that's a live video feed, constantly updated, giving you a dynamic reflection of the real world. Its whole purpose is to get us out of firefighting mode and into a state of proactive, predictive planning. So, how do we actually build this thing? That brings us to our next section, from chaos to order, which is all about building that foundation with data and standards. Look, capturing reality is the first step. Sure. But the real challenge? It's taking that absolute tidal wave of data and wrestling it into a single organized, reliable source of truth. That's where the magic and the hard work really begins. And that journey literally starts out in the field. You've got firms like the ones on GSA's big IDIQ contracts using these incredible laser scanners to capture millions, sometimes billions of data points. They're creating what's called a point cloud. But that raw data is just a cloud of dots. The real work is processing it, cleaning it, aligning it in a coordinate system, and then this is the key part, converting it from a dumb collection of points into a smart, semantically rich building information model. A BIM. That's the first big leap. Okay, but now you have all this data coming in from everywhere. Architects, engineers, surveyors. How do you stop it from becoming an absolute mess, a digital free-for-all? Well, the answer is the Common Data Environment, or CDE. This is a concept that's been standardized globally by ISO 1965, and it's a game changer. You really can think of it as the project's central nervous system. It's the one single source of truth that everyone plugs into. This ISO 1960-50 standard isn't just a vague idea. It defines a very specific workflow. It's brilliant, actually. As you can see here, and folks like Autodesk have detailed this really well, information doesn't just get thrown into a shared drive. No, it moves through very specific, controlled stages. A team works on their part in a work in progress area. When it's ready, it has to pass through a gate to be shared for others to see. Then, only after another formal review and authorization does it get published for everyone to use. And the whole time, everything is logged. You have a perfect audit trail. It's all about control and quality. Okay, next section, making the model intelligent. We're moving from a static blueprint to a dynamic twin. Because look, having a perfect model is great, but a model is static. A twin is intelligent. This is the part of the process where we actually define what this digital twin is supposed to do. This is where give it a brain. Here's the absolute key distinction we have to grasp. A 3D model is a digital blueprint. It's a fantastic static picture of what was designed or what was built. That's it. A digital twin, on the other hand, is a living, breathing mirror. It's hooked up to real-world data, maybe from IoT sensors, and it represents the past, the present, and this is the critical part. It lets you simulate the potential future. Now, to build that intelligence, you need precision. You can't simulate reality with vague information, and that's where the levels of development, or LOD, come in. This is a standard framework championed by groups like the Digital Twin Consortium that the entire AECO industry uses. It's basically a scale that defines how much detail is in the model. An LOD 200 is like a schematic design, just the basic shapes and sizes. But as you move up to, say, an LOD 350, you're getting super specific details, right down to the connections needed for actual fabrication. It ensures everyone's speaking the same language of detail. All right, this next section, the human machine challenge, brings us to what is honestly the hardest part of this whole equation. And guess what? It's not the technology. The tech is pretty much ready. The real challenge is our organizations, because you can build the most perfect, elegant digital twin in the world, and it will be completely useless if people don't know how or don't want to use it. So, the technology is ready, but are our organizations? This is the question that leaders across the entire AECO world are wrestling with right now. They're realizing that successful adoption isn't a tech problem to be solved. It's a social and organizational challenge to be managed. At the end of the day, success or failure almost always comes down to people and process. And check this out. This is fascinating. It turns out that organizational culture is a massive predictor of success. Research shows that so-called adhocracy cultures have by far the most positive impact on digital transformation. What's an adhocracy? It's a culture that's all about being agile, innovative, and dynamic. It's the opposite of a rigid top-down hierarchy. These are the environments where new ideas, like digital twins, can actually take root and flourish. And if you look at why these big tech initiatives fail, the reasons are almost always human. It's the same story over and over again. Leadership has unrealistic expectations. Nobody clearly explains why we're even doing this. People's day to day needs are understood. And maybe the biggest one, employees just don't have the time to stop their day job and learn a whole new way of working. Any one of these can completely derail a project. I love this quote. It comes from AI adoption research. And it's such a powerful way to think about this. Treat a new complex system like an intern in the company. It's brilliant, right? An intern shows up with a ton of raw potential, but they don't know anything about your specific business. You have to train them, give them context, guide them. You have to build them into a valuable team member. It's the same with a digital twin. It needs human experience to become truly effective. That's what sense making is all about. Okay, so let's bring it all together. When you nail the technical foundation and you get the human side of the equation right, what's the payoff? That brings us to our final section, building resilient futures. This is where we see the tangible high impact results that make all that hard work worthwhile. Let's take a real world use case, disaster response. Imagine a hurricane or an earthquake hits. The old way, teams on the ground slowly, painstakingly inspecting damage, building by building. It could take weeks. The new way, the digital twin kicks in. AI scans the latest aerial images, instantly flags damaged structures, cross references that with housing and economic data to calculate the financial impact, and boom, city leaders have the data they need to request the right amount of aid and get it to the right people fast. Or think about a huge systemic problem, something that feels almost impossible to solve. In the US alone, about a third of all K to 12 school buildings are old and inefficient. We know this, but we don't have the money to upgrade all of them. It's just not feasible. So what do you do? Where do you even start? This is where that what if machine really shines. With a digital twin of the entire school system, policymakers can run countless simulations. What if we put new windows in these 50 schools? What if we upgraded the insulation in that district? They can test every variable to find the sweet spot, the upgrades that deliver the biggest carbon reduction and energy savings for the lowest cost. It's about making sure every single taxpayer dollar is spent for maximum impact. So, if there's one thing to take away from all of this, it's this. A digital twin is not a piece of technology you just go out and buy. It's not a product. It's a new organizational capability that you have to build. It's like a muscle. You have to cultivate it by integrating the right technology, the right processes, and above all else, the right people. And that leaves us with one final thought to chew on. The truth is, a digital shadow of our world, all the data, all the models, it already exists. It's just scattered everywhere in 1,000 different places. The real challenge, but also the incredible opportunity for every single one of us in this profession, isn't just to find that data, it's to figure out how we assemble it, how we connect it, and ultimately, how we teach it to think. If this episode sparked a new idea, share it with a colleague. Make it part of your Monday conversation. Follow for next week's deep dive into the tools and people driving the future of digital twins.